Hello, and welcome to the Computer Engineering San Jose State 2018 Summer Internship Program. Let's begin. First, an overview. First, I want to clear up what the summer internship is for. What are the internship projects? And in that, I will go over the SJ2 project, the motherboard project, as well as the telemetry project. Following that, I want to explain what this internship can actually do for you, as well as what impact this will make on the department after you're done. So first, let's go over the CmpE summer internship. So what is it? The whole point of this is to give students an opportunity to gain technical work experience, develop a software and firmware framework for our students to use in their embedded classes, in this case, CmpE 30, CmpE 146, and so on and so forth. To demonstrate a new experimental lab project for the CmpE curriculum, this would particularly be for motherboard, as that could be the basis for what we do in 127. And also to improve the user experience of interacting with hardware. And this is relating to telemetry and making a more powerful tool for interacting with the SJ2 board. So let's go into the internship projects. First, we'll start with the SJ2, or SJDev2. It is a firmware framework for the SJ2 development board, which you can actually see on the left-hand side picture. This will incorporate developing software to control hardware peripherals, like the GPIO, the pins, setting them high or low, PWM, UART, as well as I2C. Retrieve information from hardware devices. So for example, there's onboard accelerometer, temperature sensor, and there's also an OLED display on there. You should be able to retrieve information from the sensors and also be able to control them as well. Speaking of the OLED display, we'll also be, we need a library for 2D graphics so that we can draw things on the OLED display. We'll also need, I'd also like actually to create a command line interface that would make it really easy for users to be able to prototype with the development board. And that actually goes into the last area, which is building a user space I/O file structure. But there's actually way more than just this. If you go to the SJDev2 repo on my GitHub, you'll actually see all the different things that I want to have implemented. One of the things to note is that it is completely written in C++17, and it's going to be fully unit tested. The game plan is that for every driver you develop or every bit of software you develop, it must be unit tested. If you don't know what C++17 is, you should look into it and look into the new features that C++17 has. Also, keep in mind that this project is actually made completely from scratch. So you guys will be developing an entire framework from scratch or being a part of one. And that's, in a nutshell, what the SJDev2 internships is. Building on your code for an embedded system using C++17. Next up, we have motherboard. The whole point is to build a custom computer system using FPGA, MIPS processor, and MIPS assembly. Now, the interesting thing about this is that for every person who's on this particular project, each one of them will have their own custom project that they can do on their own. You have full freedom to do whatever you please, unlike in SJDev, where there are pre-assigned projects that you can work on. Although I'll go into a little bit later about coming up with your own projects if you desire for the other projects. So project requirements. So if you're doing a project for motherboard, you need to use the above, so an FPGA, MIPS processor, and a MIPS assembler. But then you also need to use data from an external input device and control an external output device. For example, you can use an ambient light sensor and a power LED. And whenever it gets dark in the room that you're in, the ambient light sensor will read that. Your processor will read that information in, do some calculation to see how bright the LED should be, and then basically you'll have an automatic flashlight in a sense. So what are you given in order to do this? You're given a MIPS processor module, a VJ terminal module, which is actually the display that you see on the left-hand side, a keyboard module, so you can interface with a keyboard. This can be useful if you want to be able to create your own little command line interface. And you get your typical gates, like NAND gates, AND gates, or tri-state buffers, as well as memory devices like FIFOs, stacks, RAM, etc. And then for telemetry, telemetry is a web serial monitor interface to communicate and interact with hardware serial port devices. It's a bit of a mouthful, but really what it's saying is you should be able to plug in the SJ2, SJ1, your Nexus boards. You should be able to plug them into your computer and be able to interface with them textually from this interface here. But I want to expand this beyond just being a simple terminal. I want to add a lot more features. So what does this project involve? It involves adding features to the current web interface. Like for example, I would like to have a button that you can click in order to flash your SJ1 or SJ2 board, or really any board for that matter. I want it to be dynamic. We should also be enhancing the current features of the web interface. For example, if you look on the left-hand side, I'm actually using a text area in order to hold all the text. But I actually want to switch that over to using Xterm. So that actually has all the different capabilities that a terminal would have, like colored text and stuff like that. Improving the backend server. So whenever we add a new feature, we need to make sure that we also add it in from the backend, not just from the front end. So it's also useful to make edits there, as well as exploring new ways to improve the user experience. So if you guys have any ideas about, once you guys start to get a look at telemetry, about how we can make it even better, make it even more expansive, I'm more than open to ideas when it comes to telemetry. So what can this internship do for you? Well, the internship is set up to do the following things. One, to allow you guys to gain work experience. This can be another line item on your resume, and you guys absolutely should put this on your resume. It allows you to build a GitHub portfolio. If your GitHub is mostly empty, this can add some weight to it. So if you actually have a project where you've worked on open source, you can add this onto your GitHub repository. The hope and the desire for this is actually that for every project, you will fork off my repo, do some work on your own repository, and then for telemetry and for SJ Dev, you would then do a pull request back in and put your implementation there. But it'll just show that you forked off and you did some work and then you supported an open source project that's actually used by many people. Will be used for many people. You'll be working on a large project. A lot of times when you're in school, you end up working with 1 to maybe like up to 3 people. Usually don't work with any more than that. With this, you'll get experience with working on a large project where there are certain standards that you must uphold. Not only that, but when you work on this project, it's not just large just for us. It's large because it's meant for a lot of other people. A lot of people are going to need to use this, so we need to be able to support what type of software that people need to do, or software or projects people will be developing on this. You also go through code reviews. Typically, students rarely get a chance to get their code proofread by someone else. Usually, it comes in, it's graded, and you just get it back. But with this, you won't have the option to not have, the only way that code can actually get into the repository is through code review. Next, you'll learn how to properly test. So, just like I said before, everything will be properly unit tested in SJ Dev. For motherboard, you'll make sure you'll design test benches that'll test out your systems. In telemetry, I'm still working on trying to bring this in. That might be a feature that someone else, per the internship, will have to work on. And lastly, gain a deeper understanding. The hope is that by working on telemetry or SJ Dev 2 or on motherboard, you'll gain a greater understanding about the systems underneath what you work on typically. So that's kind of what it'll do for you. You'll gain all this knowledge, you'll be able to add this as a work experience, and you'll start to grow your portfolio. But what impact does this make? What's the whole point of doing this project in the first place? Well, the impact comes in three ways. SJ Dev 2 is a software suite that will be used by all SJSU CmpE students. If you remember CmpE 30, and if you're a transfer student and you don't know about CmpE 30, it's an intro class right after E10, where students develop code in C and have to use an SJ1 board to build a project of some sort. And each one of those students who comes in will get experience with developing this using our framework. Next, you'll get the development environment ready for students by spring 2019. So the hope right now is that we'll get this ready for them so that we can move from the SJ1 board over to the SJ2 board. The inspirations for why we'd even move to the SJ2 board is the fact that the SJ2 board is around about half the price of the SJ1. SJ1 is about $80. The SJ2 should be around about $45, hopefully less, depending on who we get to manufacture our parts and if I can find any other ways to cut the cost. But if we get this ready, then it'll make the CmpE department far more sustainable. It'll cut student costs. Motherboard, this project is an example of what CmpE 127 could be for all people who've taken it prior to Dr. Osmek and Dr. K's takeover. You'll understand why this is probably a good way forward. For those who've taken it afterward, you'll probably also understand that this is a good way forward as well. No more wire wrapping if you have to use an FPGA. Let's also test the feasibility of this project as a course project. Preferably for the course, it might be a group project, but I want to see what could be built with this project. And after these projects are built, we can prepare project demos for the CmpE department to showcase what we have done during the year. And finally, telemetry. Improving this improves the experience that SJ2 users have, and SJ1 users, or anyone who wants to use the terminal. Overall, you make it easier for them to be able to properly develop their code. So you're writing a tool, like in a sense, like industry tool that other developers will then use to better make their projects. And the plan for this is to actually get the new features rolled out by the end of summer, so fall 2018. Thank you for watching.